So we've got some issues with some of the inequalities we want to solve, and it comes down to this, right? What if we have negative 3x is greater than negative 21, right? So I got negative 3x is greater than 21. So just like in the previous video, what I want to do is I want to divide both sides by negative 3, right? And I want to have x is greater than 7. And everything seems like it's going according to plan. When I go to my graph, though, what we would have done last time is say, oh, okay, well, I know that my answer is at 7. It's an open circle because I don't have the equal to, and I'm going to shade up. Okay? But if you look at this, let's just test one of these values. What this is saying is that 8 is a value that makes this work, right? Because that's the way my arrow shades. If I go back to the original equation, let's see if 8 actually makes this thing true. If I plug an 8 into this, I get negative 3 times 8. Is that greater than negative 21? Well, this will be negative 24. Is that greater than negative 21? Now, 24 is a bigger number than 21, but when we're talking about negatives, it's kind of the flip-flop, right? Like, I would rather be in debt $21 than $24. So actually, this thing's false, right? This is going to happen every single time that we divide by a negative. So as soon as I divide by a negative right here and divide by a negative right here, what I've got to do when I bring this down is I got to flip this sign. So now what I'm really looking for is all the numbers that are less than, right? The reason why this is the way it is like if we have equality, right? 3 equals 3. I can do anything to these equations and it's going to hold its truthiness, right? So if I multiply this by negative 2 and this by negative 2, I get negative 6 equals negative 6, and it's true. However, if I have something like this, 3 is greater than 2, which is a true statement. If I multiply both of these by negative 2, watch what happens. Suddenly I lose my equality because now I have negative 6 is greater than negative 4, and 6 is a bigger number, but same thing, right? I would rather be in debt $4 than $6. So with inequality, because size kind of flips when you talk about negatives, we need to flip this sign every time we multiply or divide, right? So if we have something like this, get that equal sign out of there. If we have something like this, we want to solve it, right? So I want to subtract 7 from each side, and what I have is x over negative 3 is less than or equal to 3. So now what I want to do is I want to multiply both sides by negative 3, and I can hear as soon as I say multiply by negative 3, an alarm bell should be going off in your head. This cancels out, I get x. This is negative 9, and the last step is when I multiply by negative 3, I need to flip that sign. Okay. And so now what I want to do is when I graph it, I've got negative 9 right here, right? And here's negative 8, one bigger, and here's negative 10, one smaller. I'm looking for the numbers bigger than it. So it's a filled-in circle at 9, right? Because we've got the or equal to, and I'm looking for all the numbers larger. And so that's what happens. It's every time you multiply or divide by a negative.